Alright guys, this is Mr. Manise here again with another super cool video. In this video I'm going to walk you through how to solve each problem on quiz review number 1 in a coordinate geometry unit. So without further ado, let's go ahead and jump right in. Okay, so number 1 is asking us to identify the center and the radius of each circle and then sketch the graph. Okay, so these problems are pretty easy. If you'll remember, the standard form of my circle is parentheses x minus h squared plus y minus k squared equals r squared. And once again, why is it a minus? Because remember, this is basically a squared plus b squared equals c squared, and this equation is derived from the distance formula, which has minus signs in there, which is derived from the Pythagorean theorem. Okay, so this middle sign will always be positive. Okay, so this guy right here, that is my h, and that guy right there is my k. But remember, the formula has the negatives in there, so we have to go backwards. We have to flippy flip. So let's go ahead and write down what our center is. Our center is going to be flip that guy, flip that guy. Our center is going to be 3, 2. All right, and then there are two things that we need for every circle. We need the center and we need the radius. Okay, so this is, but you got to remember, this is r squared. Okay, so to find the radius, I have to take the square root of that, and the square root of 16, of course, is 4, so my radius is 4. Okay, so as we discussed in the other video, if I want to graph the circle, the first thing I need to do, of course, is plot my center. So I'll go right 3 up 2, and again, take just a moment to make sure, right 3 up 2, right 3 up 2. Make sure that point is correct, or everything else will be wrong. And then for my radius, I just simply count up, down, up, down, left, and right. So I'll count up 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. Okay, we need 4 extra points for a total of 5. And then let's go ahead and try to sketch our circle. I like to kind of do it one quadrant at a time. Do it slowly so I can get a halfway decent circle. Okay, pretty happy with that. Alright, so that is number 1. Number 2, same thing, we're identifying the center and the radius. Okay, so my center is going to be, flip that, but there is no parentheses here. Okay, so remember, this is like y minus 0 squared. So my k value is actually 0. So my center will be, flip that sign. So my center will be -1, 0. Alright, and remember, this is r squared. Sorry, I can't say that. Remember, this is r squared, so your radius is the square root of 4, which is 17. Just kidding. Alright, so let's go ahead and graph our center, -1, 0. Okay, take just a moment. When one of your h or k values is a 0, a lot of students will make that mistake and they'll plot 0, -1, so make sure you plot this correctly. My radius is 2, so I'll go up 2, left 2, down 2, right 2. And let's go ahead and try to graph that circle. Yeah, not my best. Alright, so that's 1 and 2. Alright, now notice in number 1 and number 2, we are in standard form of the circle. We're in this form, x minus h squared plus y minus k squared equals r squared. However, look down at number 3 and number 4. We're not so lucky. We're not in this standard form. So to get into that standard form, I must do what? I must complete the square, and I must complete the square twice. So if you remember from the previous video, what we're going to do is we're going to combine our x terms together. So let's put those guys together. Let's put our y's together. We'll have a plus blank and a plus blank. And remember, that constant needs to be on the right-hand side of the equation all by himself. It already is isolated, so we're good to go. Alright, so I'm just going to bring this down here so I have a little bit more room. Make sure you guys can see this. Okay, so let's go ahead and match up the x's. I'm going to have an x squared plus that 6x, and then once I match those together, I'm going to have that magical plus blank. I'm going to match up the y's, y squared minus 8y. So that's going to be plus y squared minus 8y. Here's another magical blank. and then that's going to be equal to negative 21. Now here, when I'm completing the square for the equation of a circle, I have 2 blanks on the left, I will have 2 blanks on the right. So I have a plus blank and then a plus blank. Now remember, when we complete the square on a quadratic to go from standard form to vertex form, both of my blanks are on the right hand side of the equation. That's different. That's where we have to offset that value. But here, 2 blanks on the left, 2 blanks on the right. How do I complete the square? Half of b squared, half of b squared. Hopefully you got ingrained in your brain by now. Half of b squared, so half of 6 is 3. I'm going to square that. That equals 9. So I'll stick a 9 in that blank. Alright, if I stick a 9 in that blank, that means I have to stick a 9 in this blank. 9 bricks on the left, 9 bricks on the right. Okay, for the y's, half of b squared, so I'm going to take negative 8 divided by 2. That's negative 4. I'm going to square that. So it'll be a 16 in that blank, and a 16 in that blank. I guess I could draw another arrow over here. Okay, so we have completed the square twice, and now I'm ready to factor my perfect square trinomial, which is the whole reason why I'm completing the square, so that I can take that guy and factor that easily. How do you factor that? It's just half of that number. I'm always going to have a parentheses squared piece. You can just go ahead and write that down, parentheses squared. And then half of that value is 3, so it's x plus 3. If that had been negative 6x, it would be x minus 3. And then over here, I also have another perfect square trinomial. That factors as half of the middle term, so half of negative 8 is negative 4. And remember, that's a plus sign because it's a squared plus b squared equals c squared. So I take half of negative 8, which is negative 4, so I have y minus 4 squared. And then on the right-hand side, I simply combine my like terms. 9 plus 16 is 25, minus 21 is 4. So that equals 4, and now I'm back into our standard form of a circle, where I can easily identify the center and the radius. The center, flip, flip. That's negative 3, positive 4. Remember, that's r squared, so my radius is actually 2. Alright, so let's go ahead and plot our circle, starting with the center at negative 3, positive 4, 3, positive 4. Okay, let me just check that. 3, negative 3, 4, negative 3, 4. Yep, got that. Okay, radius is 2. 1, 2, 1, 2, 1, 2, 1, 2. Let's see if I can draw a better circle this time with a radius of 2. Okay, maybe that's a little bit better. Alright, number 4. We are in this general form here, so it's the same thing. I need to get my x's together, my y's together, so I'll bring this guy on down right here. So I'm going to match up the x's, x squared plus 6x, there's our first plus blank, and then plus the y squared, where's the other y, plus 6y, plus blank, equals, now what do I have to do with that guy? I have to move that guy to the other side of the equation, so that needs to be a negative 14, and then I'm going to have 2 plus blanks. Okay, so let's go ahead and complete the square. Half of b squared, half of 6 is 3. Hopefully by now, guys, you have this down. That's going to be 9, and then half of 6 squared is also the same thing. That's 9, so I'm going to have a 9 everywhere. A 9 right there, a 9 right there, a 9 right there, and right there. Okay, so we're ready to factor our perfect square trinomial. Half of 6 is 3, so that will factor as x plus 3 squared. I've got a plus sign here. Half of 6 is 3, so I have a y plus 3 squared. Combine my like terms, that's 18 minus 14, that's going to be equal to 4. And there we go. There's the equation of my circle. So this almost looks just like the previous one. So flip, flip. So my center is negative 3, negative 3. Okay. And that's r squared. So my radius is the square root of that, which is 2. We've got lots of diameters of 2. Okay, so let's plot our center. Negative 3, negative 3. So I'm going to be in the third quadrant. And I've got a radius of 2. So I should be plotting this in purple. 2, 2, 2. Dose. Okay, so let's go ahead and draw our circle here. And remember guys, if you're still not sure about this whole completing the square stuff, you can go back and watch the previous video. Take it slowly. I'm going to kind of assume that you guys are a little bit more comfortable with completing the square. Okay, and there we go. That's problems 1 through 4. All right, let's keep going. Making good progress here. All right, so down at the bottom, I'm going to make some room here on my desk. I'm not used to working at home, making videos at home. Okay, so at the bottom here, we've got use the information provided to write the equation of each circle. Okay, so let's write this down again one more time. X minus h squared plus y minus k squared equals r squared. Okay, so they give us, what two things do we need, guys? We need the center, we need the radius. Okay, I got the center, check. But I need the radius. Now, I would encourage you guys to draw yourself just a quick little picture. Sometimes we'll have a coordinate grid. These don't give us a coordinate grid. So if I give you guys this quote-unquote take-home quiz that I'm just going to grade as a probably a double task homework grade, then you guys are more than welcome to just go to Google, print off a piece of graph paper. If you got your own graph paper, print it out, plot the circle, use Pythagorean theorem like I taught you in class. It's no big deal at all. Okay, so let's draw ourselves a little picture of what's going on here. All right, so I got a circle, and I've got the center, which is at -2, -7. I've got some point on the circle. So let's say that -2, -7 is down here, and 5, -3 is the center is -2, -7, and we got a point on the circle, 5, -3. It doesn't really matter where I'm drawing these points. Okay, I just got a center and I've got a radius. So I've got a center and a point on the circle. Okay, so how do I get the radius? I need to find the distance between those 2 points, right? Okay, so again, you could use Pythagorean theorem on the coordinate grid if you had a piece of graph paper. I'm going to go ahead and use the distance formula. Distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I'll let these guys up here be my 1s. I'll let these guys over here be my 2s. Again, it doesn't matter. And I just plug and chug into my formula after I get my camera to refocus. These. Okay, here we go. All right, so distance between the center and a point on the circle is going to be x2, I'll call that guy, square root of 5, minus x1. Now remember, this is a little tricky. I'm subtracting a negative, so I'm going to put double set of parentheses there. I'm subtracting the -2 plus y2, -3, minus y1. Double tricky, squared. Got 2 sets of double negatives, no problem. So this is going to be the square root of, that's going to make that a plus, so I got 5 plus 2 squared, that's going to be the square root of 49. And we've got -3, that's going to make that a plus 7. -3 plus 7 is 4, so that's going to be plus 4 squared, which I'll just go ahead and write down 16. Okay, so the distance is going to be the square root of 49 plus 16, which is 65. All right, so that's our distance, which is our radius. So radius is equal to the square root of 65. Now, I'm going to leave this as a radical again, guys, because we're going to have to square it on the back end anyway when we write our equation. So I have the center, put a check here. I have the radius, put a check here. I've got both things. I'm ready to put this into my equation. So the equation is always going to be, again, going back to our equation, x minus h. But remember, we got to flip the signs. So if the center is -2, I got to flip that. That's going to be x plus 2 squared. Anytime I go from center to equation or equation to center, I have to flip those signs. Plus, flip that guy. This is going to be a y plus y plus 7 squared equals, now the radius, remember in the equation this is r squared, but our radius is the square root of 65. So if I square the square root of 65, they just cancel each other out. I'm just left with 65. So 65 is the number that goes on the right-hand side of the equation. Okay, so again, pause that, rewind if you feel like you need to. Let's continue on. Number 6 is the same as that thing. It's just more practice. Okay, so I've got a circle here, I've got a center, I've got some point on the circle. Okay, so I need to find this distance I should have drawn that over here. I need to find that distance, which is the radius of my circle. There we go. I think I should buy a new webcam. It goes out of focus too easily. Alright, so here we go. Same thing as last time. So I'm going to find the distance between those 2 points. Actually, yeah, I'll go ahead and do that. I was actually going to come up here and do the Pythagorean theorem on the coordinate grid, but you guys have seen that. We've done it in class, so again, I'll let you guys do that on your own if you want to. I'll just do the distance formula again. x1, y1, x2, y2. So my distance is going to be the square root of x2 minus x1, so I have -1 minus a -7, double parentheses, squared, plus 2 minus a -4, double parentheses, squared. Okay, so distance is equal to, that's going to make that positive, -1 plus 7, that is 6. I'm going to square that, so 6 squared is 36. 2 minus -4 is 2 plus 4, which is 6. I'm going to square that. That is also 36. And so the distance is going to be the square root of 72. That is not a perfect square. So again, I'm going to leave that as a radical. So the distance that we just found is the radius. Okay, so r squared will be the square root of 72 squared, which is 72. Sorry, I can't see that. Okay, so we got the center. We got the radius, or r squared. Okay, so if I plug this into my equation, I'm going to have x, flip that sign, x plus 7 squared plus, flip that sign, y plus 4 quantity squared equals r squared, or the square root of 72 squared, which is 72. All right. Okay, so that's the first page. Moving right along. Okay, so let's go to the back. Alright, these are where it gets a little bit harder. Okay, so instead of giving us the center and a point on the circle, all they give us are 2 endpoints. Okay, so again, let's draw ourselves a little picture here and see what in the heck's going on. So we've got a point here, and I've got a point here. Okay, those are the ends of the diameter, so that goes through the center of the circle. Okay, so what 2 things do we need? We need the center and the radius, right? Okay, we don't have either of those, so I need to find both. Okay, now it doesn't really matter which one you find first. We're going to use the midpoint formula to find the center. We're going to use the, I'm going to use the distance formula again to find the radius. So if we find the distance between these 2 outside points, we can just divide that by 2 to get the radius. So I'm going to go ahead and do that first. Let's let these be the 1s, and let's let these be the 2s. Alright, so distance is going to be equal to x2 minus x1. It's a lot easier when I have all those double negatives. Plus 2 minus 1 squared. So that's going to be the square root of 3 squared, which is 9, plus 1 squared, which is 1. And so the distance is the square root of 10. But remember, the distance that we just found was the distance of the diameter. So don't make that mistake. So the radius, we got to cut that in half. The radius is the square root of 10 over 2. Again, I'm going to leave that as a radical because we're going to have to square it on the back end anyway. Now, the next thing that I need is the midpoint. I need to find the center. Okay, so the midpoint formula, I'll write that up here if you guys remember, is the average of your x's, x1 plus x2 divided by 2, comma, the average of your y's, y1 plus y2 divided by 2. Okay, so let's add our x's together. So the midpoint is going to be 4 plus 7 divided by 2. Add the 2 x's, comma, add the 2 y's. 1 plus 2 divided by 2. So the midpoint, or my center, is going to be 11 halves, which is 5.5, comma, 3 halves, or 1.5. Again, if you want to leave that as a fraction, perfectly fine. I think we left it as a fraction class. On the video, I'm doing it as a decimal. Okay, so I got the radius, check. I've got the center, check. Now I'm ready to plug it into my formula. So I've got x. The center is that guy, so I've got to flip those 2 signs. So it's x minus 5.5 squared plus, flip that guy, y minus 1.5 quantity squared equals r squared. Now when I square this, guys, when I square this piece, I have to square the top and the bottom. Okay. Come on back into focus. Okay, now when you square a fraction, guys, you square the top and the bottom. So when I square the top, the square root of 10 is just 10. And when I square the bottom, 2 squared is 4. So I end up with 10 fourths, or 5 halves, if we simplify this. I'll just put in parentheses 5 halves. We should always simplify our fractions. Okay, so that is number 7. Okay, number 8 is the exact same thing. So once again, I have 2 endpoints of the diameter. Okay, so I'm going to use the distance formula and then divide by 2. Again, guys, Pythagorean theorem on a piece of coordinate paper, a coordinate grid, graph paper is perfectly fine. So distance equals the square root of x2 minus x1. So I've got 6 minus a negative 5 squared plus y2 minus y1. Get these double negatives again. That is okay because we can tackle that. That's going to be a 6 plus 5. That's 11 squared. Okay, so that's 121. And then negative 1, that's going to make that a plus 3. Negative 1 plus 3 is 2. 2 squared is 4. So the distance is the square root of 125, which is not a perfect square. Okay, so what we just found was the diameter, so the radius is going to be half of that again. So square root of 125 divided by 2. Midpoint is going to be negative 5 plus 6. I just add those x's together, divided by 2. Add the y's, negative 3. I'm just adding them, so it's just negative 3 minus 1. And so my center is going to be, that's going to be 1/2, comma, negative 4 over 2, which is negative 2. This one I'm going to leave as a fraction. Okay, so I've got the radius check. I've got the center check. I'm ready to plug into my formula. So I've got x, flip that guy, x minus a half, quantity squared, plus y plus 2, quantity squared, equals, again, now when I square this, guys, what do I get? When I square the top and the bottom, I'm going to get 125 over 4. That does not simplify, so that is your final answer. Okay, very good. Making good progress. All right, now these are, well, these first two are pretty easy, and then the number 11, number 12 are probably the hardest ones on the review that you'll see on the quiz. So it says, identify the vertex, sketch the graph, and describe the transformations that occurred. Okay, so when we're in vertex form, that's really easy. Y equals a times x minus h squared plus k. All right, when we're in vertex form, then it's easy to identify the vertex of the parabolas. Okay, everything we just did was circles. Okay, now these are all quadratics, parabolas, U-shaped graphs. Okay, all right. So to find the vertex is going to be h comma k. So I'll write that up here. Vertex is h comma k. But remember, anytime I got this parentheses squared piece, what have we always been doing? We've been flipping the sign, right? When we solve a quadratic and you get x plus 4, you flip the sign. When the equation of a circle, x minus h, you flip the sign. Vertex form of a parabola, x minus h squared, you flip the sign. And I keep saying that because I'm waiting on my camera to refocus. Maybe it just doesn't work in my house. That's entirely possible. Hey, welcome back. Okay, so this one, the center's easy. I flip that sign, leave that guy alone. So the center is negative 4, comma, negative 3. Okay, and then now I've got 4 potential transformations that I've talked about in the previous video. The first transformation, like reading a book from left to right, I don't look at the y. I look at everything to the right of the equal sign. The first thing I look for is, do I have a negative? If I do, then I have a reflection. The next thing I look for is there a coefficient? Do I have this a value? Okay, that's going to be your stretch or your shrink. If it's greater than 1, if the absolute value is greater than 1, then it is going to be a stretch. If it's between 0 and 1, like a fraction, 1/2, 0.3, something like that, that will be a shrink. Okay, and then the next thing I'm looking for is the inside the parentheses squared piece. That's your horizontal shift, but remember it's backwards. And the last thing is your vertical shift. Okay, so do I have a reflection? No, I don't. Do I have an a value? Yes, I do. So my first transformation is a stretch because that absolute value is greater than 1. I'm going to say stretch of 3. Don't just say stretch. Say stretch by 3 or stretch of 3. Next thing is I got a horizontal shift. Remember, it's backwards. So you're thinking 4 to the right, but it's actually 4 to the left. So we're shifting left 4. And that's a -3. That's a horizontal shift, so that's going to be down 3. Okay, so that's pretty easy. And now it says to sketch the graph. Okay, so to sketch the graph, I'm going to plot my vertex first. So let's go to -4, -3. Okay. All right, and then now, remember from the previous video, how do I graph my other points? Okay, now you can do it the old school way and just grab some x values up here to the left and to the right of this vertex and plug them in and get your output, but it's a lot easier to just use your calculator. Okay, so I'm going to get my trusty calculator. I'm going to go to y equals, clear whatever's in there, and I'm going to type in my equation. Maybe I need to zoom out a little bit. Let's see if that helps. Sorry about this, guys. I seriously going to have to look at a new webcam, so I'll have to keep doing this. Okay, so let's type in our equation up here. So we've got y equals 3 parentheses x plus 4 quantity squared minus 3. All right, first thing I'm going to do is I'm going to graph it. I just want to see what it looks like, because a lot of times if you graph it, you'll get a line. Why do you get a line? Because students love to forget to put quantity squared. If you don't have that squared there, you don't have a quadratic. You have a line, okay? So yes, we do have a quadratic. Yes, that vertex is in that third quadrant like I think it is. And then I'm going to press second table, or second graph. And let's get some points here. And just like I discussed in the other video, I'm going to scroll down to my vertex here, and -4, -3. I'm going to make myself a little t-chart. So I've got x, y. Okay, so I'm going to grab the 2 points above the vertex. So I'll grab the -6, 9, -5, 0. There's my vertex, -4, -3. I like to put a box around that, so I'll make sure I get the 2 above and below. And the next 2 points, -3, 0, -2, 9. And I'm ready to plot my points. And notice, guys, that it's symmetrical. These y values are perfectly symmetrical around the vertex. If those numbers don't match these numbers, then you did something wrong. Okay. All right, so next point is -5, 0. That's right there. And then we got -6, 9. That's off the graph up here. That's okay. -3, 0. Now, actually, once I plot those 2 points, I really don't even need to look at the t-chart because I know it's going to be perfectly symmetrical. If it's right there, it's going to be right there on the other side. Right there on the other side. So now I can sketch my graph. Notice that this graph is a little bit taller and skinnier than normal. Why is that? Because we have a stretch of 3. Stretch of 3 right there. Okay. Okay, so let's keep going. We got another easy one here. You might want to pause the video if you're working through this as you're watching. Pause it and make sure you've done this correctly. Okay, so what is our center here? Our center, excuse me, I'm still on circles. Vertex, okay, our vertex is flip that guy, leave that guy alone. So the vertex is +3, -2. All right, what transformations do I have? I have all 4 of them here, okay? All 4 possible transformations. I've got the negative, so I've got a reflection. Now, in the previous video, guys, I said that you can just say it's a y reflection. It's not truly a y-axis reflection, but sometimes we just say it's a y reflection just to denote that I'm flipping vertically, okay, like a y-axis reflection. In this video, I'm going to be a little bit more accurate here. Technically, we're reflecting around a horizontal line. I'm always reflecting around a horizontal line, okay? And the horizontal line is always going to be based around the y-coordinate of the vertex, okay? So if I plot my vertex at +3, -2, right there, okay, that is where the start of my parabola is, okay? Now notice that there is an imaginary line here. Okay, you can't see it. This is the imaginary line where the flip happens, okay? And it's occurring around -2. So I'm actually going to say I'm reflecting around the horizontal line, y equals -2, okay? All right, so now, what other transformations do I have? Okay, that takes care of the negative. Now, do I have an a value? Yes, I do. Now, remember, this is still a stretch, guys, because the absolute value is greater than 1. So it's still a stretch at 2. The negative just means it reflects. For this to be a shrink, it's got to be a fraction, something less than 1, between 0 and 1. I have a horizontal shift, that's right 3, because it's backwards. And I have a vertical shift down 2. Okay, now let's go ahead and grab our points here. Okay, let's go to y equals, let's type in our equation. -2 parentheses x minus 3 quantity squared minus 2. And let's graph it just to make sure my vertex is in the right spot. There we go, vertex in the right spot. Second table, and let's grab some values here. Okay, so let's scroll to the vertex. Oops, wrong way. Okay, there we go, 3, -2. It's right in the middle. And the 2 points above it. 1, -10, 2, -4, 4, -4, and 5, -10. Notice again, these perfectly symmetrical. Okay, so my next point is 2, -4. Okay, I'm going down. Why am I going down? Because it's a reflection, so that makes sense. Then I have 1, -10. That's way out yonder in the bushes, way down here. Then I have 4, -4, perfectly symmetrical, and then 5, -10, way down here. And I can draw my upside down parabola because we have a reflection around the line y equals -2. Okay, very good. Okay, here we go. The two hardest problems on the quiz review and quiz. I need to graph my quadratic, but I'm not in vertex form. So what do I have to do? I have to complete the square to get it into vertex form. Okay, now this is completely different than completing the square with the circles, guys. Okay, so what I'm going to do is I'm going to have y equals, now remember I'm only completing the square on just those two terms. Okay, so it's y equals x squared plus 4x. Here are my first two terms. Then there's a blank. There's our magical plus blank. Then I have the plus 8, and I don't know, guys, whether this is going to be a plus blank or a minus blank. It depends on what the a value is, okay? All right, so now I'm ready to complete the square. Half of 4, half of b squared. Half of 4 is 2, 2 squared is 4. So I'll put a 4 in that blank. And now normally I'd say I put a plus 4 in that blank, but remember, everything is on the right-hand side of the equation. The only thing on the left-hand side is a y. So if I put 4 bricks on the right-hand side of the seesaw, I have to take off 4 bricks to keep my seesaw balanced. That's different than the circles where you had blanks on opposite sides of the equal sign. That's not the case when you complete the square to go to vertex form with a quadratic. Okay. And of course those just cancel, and I get right back to where I started. But the whole reason for doing that is so that I have a perfect square trinomial that I can factor, and so I can easily determine what the center is. How does this factor? It factors as half of b, half of that number. So I know I'm going to have a parentheses squared piece. Half of 4 is 2, so it's going to be x plus 2 squared. And then I just, y equals, and then I just combine my like terms over here, and that's going to be a plus 4. Okay, so now I'm back into the problem that we did just a few minutes ago. Now I'm back into vertex form. Okay, so this becomes like number 9 and number 10. The center is going to be -2, 4. Flip that sign, leave that guy alone. What transformations do I have? I only have 2 of them, horizontal and a vertical shift. So it's going to be left 2, because it's opposite, and it's going to be up 4, and plus 4. Again, pause the video if you need to slow down a little bit. Center is -2, 4, left 2, up 4. All right, now let's go get some points. Okay, let's plot this. So we have x squared minus 4x plus 8. Now, I just plotted the standard form. Could I have plotted the vertex form? Absolutely, because these two guys are the same thing. We're just converting one form to the other. Okay, so actually, again, like I talked about on my previous video, you could actually plot both of these, and if they lay on top of each other, then you know you did the math correctly. That's a good way to check your work. All right, so I'm going to plot this, and let's make sure that my vertex is where I think it should be. Plus 8. Oh my goodness. Guys, I would love to say that I did this on purpose, but it's Thursday morning on March 19th and I made a mistake, and because I did what I preach, I caught my own mistake. I said, wait a minute, my vertex is in the second quadrant, but wait a minute, when I graph it, it's in the first quadrant. What had happened was I did not bring down this negative sign, so I made I made a mistake. Yep, see, nobody's immune to making mistakes. Nobody. Let me see if I can get my whiteout to work here. Actually, I'll just cross it out. I don't need to white it out. That should be a negative. Okay, and if that's a negative, when I take half of that number, that means this guy has to be a negative, which means my center is going to be positive 2, 4. And there I could catch my mistake. Whoops, my vertex is 2, 4. Surely you guys are yelling out the video, no, Mr. Manice. Wonderful. Sometimes I make mistakes on purpose. Unfortunately, that time I did not make a mistake on purpose, so I hope you guys got a good laugh out of that. But that just goes back to show you, when you go back and check your work, guys, before you get to the end, as you do these little gut checks as you go along, you'll catch so many mistakes and you'll save so much time. Okay, it's taken me, I've learned that over the past 25, 20, 30 years of my life, all throughout high school and into college and into the real world. Check your work. Okay, so let's type in, okay, so now we got the correct vertex. Let's go second table, and let's go to a vertex 2, 4, and let's grab some points. X, Y. So we got 2, 4. I've got 0, 8. Can y'all see that? 1, 5. 3, 5. 4, 8. Okay. These are symmetrical. That's good. Okay, so I got 0, 8. Which way does the graph open? I don't have a reflection, so I already know that the parabola is a right side up parabola. If there's a negative, it's an upside down parabola. Okay, 0, 8, 1, 5, 3, 5, and 4, 8. So there is my parabola. Okay, there we go. Okay, very good. Let's move on to the next one. Ooh, a little tricky, guys. What's different about this one and this one? This one has an A value in front of it. Okay, so again, I went over this in the previous video on this lesson, but let's go back and refresh our memory. Guys, I cannot complete the square unless that guy is a 1. It is not a 1, it is a 2. So I must, mandated, I must factor out that 2. But remember, I'm only completing the square on those 2 pieces. Okay, so when I factor out a 2, I'm only factoring out from these 2. So that's going to leave me with parentheses, that's going to leave me with x squared. Negative 12 divided by 2 is negative 6, so it's going to leave me with negative 6x. Here's our magical plus blank. Okay, let me pause there for a second, make sure you got that. Factor out a 2, that's going to leave me with x squared minus 6x plus blank. Then the 15 doesn't get to play, he stays outside, and then I'm going to have another blank. Okay, alright, how does this factor, or how do you complete the square? Half of b squared. Half of negative 6 is negative 3, negative 3 squared is 9. Okay, so I will put in a 9 here. Okay, so now normally you say, okay, I put 9 bricks on the right. I've got to take away 9 bricks. I have to put a negative 9 over here to offset that. Nope, 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 nope. Actually, you did not pull a 9 out of thin air. You pulled a 2 times 9 out of thin air. So you must offset that with a negative 18. 2 times 9. You put 18 bricks on the right hand side of the equation. You got to take away 18 bricks. Okay, so when you factor out that constant, do not forget to go back and redistribute it to figure out what goes in this last blank. If that A front term had been negative, I would have pulled out a negative 18 bricks, which would change this to a positive 18. Okay, so keep that in mind as well. Alright, now we've got our perfect square trinomial. How does that guy factor? Factors is half of the middle term. So I'll get y equals, you keep this 2 out front, that doesn't go away. 2 times half of negative 6 is negative 3, so that's x minus 3 quantity squared. 15 minus 8 minus 3. Okay, so now I have my vertex form. So now I can tell you easily what the center is. The center is 3 comma negative 3. Flip, leave alone. Transformations, what do I have? I've got 3 of them. I don't have a negative, so I don't have a reflection, so this is going to be a right side up U. I've got a stretch of 2. Stretch of 2. And then I've got right 3 and down 3. Okay? Alright, so for the sake of this video, guys, so it's not so long, I'm going to let you graph this on your own. So the solutions are on Google Classroom, so you guys graph it, check it with your graphing calculator, make sure you do this correctly. Okay, let's go on to the last few ones down here. Now, students love to make these extremely complicated. Guys, these are super, super easy. Super easy. It's saying identify the transformations of y equals x squared in the given function. Okay, these are just identifying the transformations. So here I've got a reflection. Well, actually, let me go ahead and write down the vertex. The vertex is what? Negative 3, 2. So on this one, I have a reflection around what? It's always going to be reflecting around the line y equals, and it's always going to be around the y coordinate. So I'm reflecting around the line y equals 2. That's one transformation. I've got left 3, and I have up 2. So only 3 transformations for that one. This one, my vertex is flip, leave alone, 4, negative 5. Okay, now do I have a reflection? No, I don't. But here I have that fraction, okay, it's between 0 and 1. So here I actually have a shrink by 1/2, or a compression, sometimes it's called a compression. Shrink by 1/2, I have right 4, and I have down 5. Okay, these last 2 guys are the ones I was talking about. Students love to make these so much more complicated than they are. All this mapping rule stuff is saying is I'm taking x and y. I'm taking some point on the parabola, and these are the things that I'm doing to it. I'm taking this point, say on this parabola, I'm taking 2 comma 4, and then I'm going to subtract 3 from it. For the x, I'm going to take the x, I'm going to subtract 3. Okay, so if I subtract 3, then that's going to give me the horizontal shift. And then everything after the comma is what you're doing to the y's. If there's a 2/3 in front, that means I'm shrinking it by 2/3. Okay, and then I'm adding 1 to the y's. Okay, so that means I got my vertical compression. I'm shrinking the parabola, and then I'm shifting it up 1. Okay, so when I go to write my equation, I look to see, do I have a reflection? No, there's no negative in front of the 2/3. Okay, so there's no reflection. Okay, do I have an a value? Do I have a stretch or shrink? Yes, I do. It's right there in front of the y. If there's a number in front of the y, that's your stretch or shrink. So I do have a shrink, 2/3. And now I'm ready for my x minus h piece. I'm subtracting 3, but remember it's backwards because it's x minus h. So I just flip that sign like we always are doing. That's x plus 3 quantity squared, and then I'm taking the y's and I'm shifting them up. So that's going to be plus 1. That's all you do, guys. It's just another way of saying a vertex form. Number 16, I've got y equals. Do I have a reflection? Yes, I do. There's a negative in front of that 2. So basically, whatever's in front of y is the very first thing that goes in the equation. So y equals negative 2y. Do I have a horizontal shift? Yes, I'm adding 5, so it's backwards. So x minus 5 squared. Do I have a vertical translation? Yes, I do. Down 3, so it's minus 3. Okay, hope you guys enjoyed that. Hope that you are getting all of these answers correct. Let me know if you have any questions or concern. Go back, rewatch the video, pause as needed, and we will see you on the next video.